Okay, students, let's start today's discussion. In this lecture, we will discuss about the equations of motion and its derivations. Students, we have three different type of equations. V is equal to u plus at, and s is equal to ut plus half at square, and we have third equation of motion, which is v square minus u square is equal to twice as. So in this lecture, we'll try and understand the derivation of these formulas. So students, all these equations describes the uniformly accelerated motions. In the last lecture, we discussed about the graphical representation of uniformly accelerated motion. So here is a velocity time graph, student, and this graph, this is the graph. This is Vt, this is graph representing uniformly accelerated motion. An object moving with uniform acceleration can be represented by this Vt graph. Now, students, this part of the graph, this point means this length. This length gives us the initial velocity, which is denoted by u. And from this point to this point, this length will give us the final velocity. Students, take a look at this example. Say suppose I have 5, this is 10, and let's say 15. Let's say initially the body is moving with speed 5. And after some time, the body's speed increases to 15. Now, when I ask you what is the initial speed, you will write u is equal to 5 meter per second. What is this 5 actually? This 5 is the length, distance, the length. This length is the 5. And when I say what is the final speed, we may say 15 meter per second, this one. This 15 is actually the length from this point, this origin to this length. So that's why we are writing here OA as an initial velocity, the length OA as a U. Length OE, this length OE is V. And similarly, this time, this length OD is time. Now, student, in the last lecture, we discussed about the velocity slope of a velocity time graph. So in this case, here we have a line. If I want to know the slope of this line. Now, to calculate the slope of this line, you remember the formula slope of a VT graph is the ratio of the perpendicular to the base in a right angle triangle. Here we have a right angle triangle. In this right angle triangle, if I take the ratio of a BC and this AC, I'll get the slope. And you also remember the slope gives us the acceleration. Velocity time graph's slope gives us acceleration. That's the formula, student. You must remember slope of velocity time graph gives us acceleration. So this acceleration, and this is BC by AC. Acceleration. Now this BC, from this diagram, this BC can be calculated as a BD minus CD. BD minus CD. This BC can be written as a difference of a BD minus CD and divided by AC. This A equals, this BD can be replaced by OA or EO minus this CD. CD can be replaced by OA or AO and divided by AC. A equals EO. Now, student, what is EO? EO or BD? BD and EO have the same value. That's how much? V. So I can replace this EO by V. Similarly, AO. What is AO? AO equals U. So this AO can be replaced by U. And what is this AC? The AC can be replaced by OD, and which can be replaced by D. D. So this AC is replaced by D. Now if I simplify this, I'll get the equation like this. AT is equal to V minus U. And after rearranging, we'll get our final equation, that is what? V is equal to U plus AT. So this is the graphical calculations of this first equation of motion, V is equal to U plus AT. Now student, let's move on to our second equation of a motion. Student, the good part of this derivation is for all these three equations of motions, we can use the same graph. The same graph can be used. So I'll be using this graph to derive the second equation of motion. So while you're deriving the second equation of motion, you have to draw this graph. For first equation of motion, separate graph. Second equation of motion also you have to draw this graph. For the third equation of motion also you have to draw this graph. So second equation of motion, student, S is equal to ut plus half at square. You know what is S? It's a distance or displacement. U is the initial velocity, T is the time, A is the acceleration. So how did we arrive at this relation? Let's understand. Now slope of VT graph, student. Again, the slope of this VT graph. So slope, we obtain here slope. Slope is BC divided by AC. Now slope, as I mentioned, velocity time graph's slope is acceleration. And this equals BC by AC. Now this AC can be replaced by T. So if I rearrange this, I'll get the value for BC as equal to AT. Now student, one more very important property. Before we proceed, we must remember this property. This is also one more important property. What is that? Area under the VT graph equals displacement. Now student, let me just write here two important points. First, slope of VT graph. Slope of VT graph gives us acceleration. That's the first important point. Second is area under VT graph equals distance or displacement. Now student, remember this two important property. You may be asked, write the two important properties of velocity time graph, and you have to write these two properties. That is, the slope of a VT graph gives us the acceleration and the area under the VT graph gives us distance or displacement. Now let's student move further, move ahead. So suppose displacement. Now from this property, area under the VT graph is displacement. This can be written as a displacement is equal to area under the VT graph. Now displacement is denoted by the symbol S and area under the VT graph. Now students, see, this is the graph. This is our VT graph. How much is the area covered by this graph? Now the area covered by this graph is the area of this trapezium. Area of this trapezium, that is OABD. So area of OABD. Now this S equals area of OABD. I can split this area of OABD into the area of rectangle and area of a triangle. This trapezium's area can be written as the sum of the area of this rectangle and sum of the area of a triangle. So area of rectangle OACD plus area of a triangle ACB. Now student, what is the area of a rectangle? You know, length into breadth. So here is the length and this is the breadth. So OD is the length, OA is the breadth. Plus area of a triangle is half into base into height. So half into base. Now in this triangle, let's consider this as a base and this is a height. So base into height. Now students, this OD, OA, AC and CB can be replaced by their respective values. Now OD can be replaced by T. So this OD can be replaced by T. OA can be replaced by U. So OA is replaced by U. Half AC. AC is how much from the graph you see? AC is equal to OD and OD can be replaced by T. So AC can be replaced by T, and CV means BC. BC equals AT. Now this BC or CB can be replaced by AT. Now if I simplify this, I'll get this final equation. S is equal to UT. U into T is UT plus half T into AT. That's AT square. So that's how we got the second equation of motion. S is equal to UT plus half AT square. Now let's move on, student, to our third equation of motion, which is V square minus U square is equal to twice AS. Again, student, for this equations also, we can use the same graph that we use for the first two equations of motion. Now students, OA equals U, OE equals V, and OD equals T. OD also equals to AC, which is equal to T. Now students, you know slope of the VT graph. How to calculate the slope of the VT graph? That's BC by AC, BC by AC. Slope means what? Slope gives us the acceleration. Now BC is BC and in place of AC, AC is replaced by T. So we got this. BC is equal to AT. Now student, from the first equation of motion, we derived the first equation of motion. You know what is first equation of motion? We will calculate the value of a T. You simply rearrange all these quantities and calculate the value of a T. You will get the value of a T as a V minus U by A. So this is the value of a T that we obtained from the first equation of motion. Now student, again we'll be using the another property of the velocity time graph, that is what? Area under the VT graph gives us the displacement. Area under the VT graph equals displacement. What is the area under the VT graph? Now area under the VT graph is the trapezium, area under the trapezium. So area of a trapezium OABD. Now area of a trapezium OABD is equal to displacement, and you know displacement is denoted by S. So now this time we will write the area of a trapezium. Students, you know the formula of the area of a trapezium, that's half into H into A plus B, sum of the parallel sides. H is the distance between the parallel sides and A plus B. Say suppose I have a trapezium like this. This is A, this is B, and that's a H. So in this graph we have, where is H for us? This is H for us, and these two are the parallel sides. This is A for us and this is B for us. So half into H equals OD. So in this formula H is OD and OA plus BD. This is A and this is B. A is OA and B for us is BD. So this is the formula of area of a trapezium is equal to S. Now this OD, OA and BD can be replaced by their respective values. So half OD equals how much? OD equals T. So this OD can be replaced by T. OA equals how much? OA equals U. So OA can be replaced by U. BD What is the value of a BD from the graph? You can see BD. This BD equals OE and this OE equals V. That means this BD can be replaced by V. So now student, we will replace this T. The value of this T will be substituted from here. We have obtained the value of a T equals V minus U by A. So this value of a T will be substituted here. So this half is here. The value of a T we substituted from here. And this U plus V can also be written as a V plus U equals S. Now if I rearrange this expression, if I rearrange, I'll get like this. And if you observe carefully, the numerator of this expression is an algebraic formula, that is what? V square minus U square divided by twice A equals S. Rearranging this, we get our third equation of motion, students. So I hope, students, you understood the derivation of the first three equations of motions. So with that, this is the end of this lecture. Thank you.